Yeah, good morning. This is the DT based delivery on unit commitment. So the unit commitment. So unit is nothing but. So here we are having n number of generating stations. Like they are producing the electricity like Beto thermal power plant, Neyveli thermal power plant, Kodangulam nuclear power plant, Kalpakkam nuclear power plant, and some of the Thuthukudi thermal power plants, and many hydroelectric power plants. So there are n number of power plants which are available. So these power plants are called as unit. So for example, in Neyveli, they are producing the electricity with the help of coals. So they are having unit 1, unit 1 expansion, unit 2, and unit 2 expansion. There are 4 units are there in Neyveli power plant. So similar way, in each unit it has some certain generating capacity. For example, the unit 1 it may be 500 megawatts. It is the maximum generating capacity of unit 1. And unit 2 will be 300 megawatt. It is the maximum capacity. And unit 3 it is the maximum capacity of 200 megawatt. So like that it may contain n number of generating stations which is used to produce the electricity in the generating station. Okay, in the Neyveli thermal power plant or hydroelectric or whatever it may be. Okay, so this is a generating station, and as well as all the generation it should meet out the demand which is required by the load section. So that is nothing but an load demand. So day by day, always the number of loads are always getting increases. Suddenly, if you are seeing on tomorrow, we are going to inaugurate the other factory. Okay, today they are inaugurating number of factory. So day by day, the building, number of AC, and all the loads, factory, everything will be increasing. So day by day, load demand is always getting increases. So this generation should meet out the load demand. So based on the load demand, we have to allocate this particular unit has to be turned on and this particular unit has to be turned off. So we have to allocate which unit has to be turned on and turned off. At what time it should be turned on and what time it should be turned off. So we have to commit the unit. We have to commit the unit when and where it should be operated or turned on. So that is nothing but a unit commitment. So okay. So also we have to see the operating cost, the more economical cost. Okay, so for example, the maximum demand is 700 megawatt. If all the 3 units are getting operating, it meeting the maximum demand. But we have to calculate the what is the total cost of unit 1, unit 2, unit 3, and if you are adding all 3 units, so what is the total cost? Suppose if unit 1, unit 2 is getting operating, it is meeting out the total demand. Okay, there we have to calculate the total cost. So out of the total cost, which one is most minimum? It is most economical one. So we have to select that unit to operate to meet out the load demand. So that is nothing but a unit commitment. So we have to meet out the demand. So based on the demand, at what time which unit has to be turned on and turned off. We have to allocate. We have to commit the unit. That is nothing but a unit commitment. So now they will play a role play. So among the 3 units, what is the maximum generating capacity, what is the load demand, whether the solution is feasible or not, and whether we have to calculate the total cost or not. So they are going to play the role play. Just start.
So I am the unit 1 generating station. Now I am in off position.
I am the unit 2. Now in off position.
I am in unit 3. I will be off position.
Okay, so normally a unit commitment there is a formula 2 power n minus 1. So n it represents the number of units. Here we are taken number of units is 3. So 2 power n is nothing but 8. 2 power 3 is 8. 8 minus 1 7. So there are 7 feasible solutions. So the 7 feasible solutions are listed out here. Okay, so that is 0 0 1 0 1 0 0 1 0 1 1 1 0 0 1 0 1 1 1 0 and 111. So it is based on the DLC. That is nothing but 0013 logic sequence. So it will be operating like this. There are 7 solutions with that. Out of 7, so how many will be getting feasible solution and how many will be infeasible? Only for feasible solution, we have to calculate the total cost. So here the unit 1, unit 2, unit 3, everything is turned off. It is will not in use.
So my total demand is 700 megawatt. So now the generating station of unit 1 and unit 2 and unit 3 is off condition. So it's 0 plus 0 plus 0 is 0. Hence it is 0 demand.
So it is not whether you are meeting out the generation which is equal to demand or not.
It's not.
Okay. They are not meeting out the load requirement.
The demand is not meted, so the I am infeasible.
Because of infeasible, I don't need to calculate the total cost.
Okay. So the next case, unit 3 is turned on.
So now unit 1 and unit 2 are off and unit 3 is on. So it is 200 megawatt. So my demand is 700 megawatt. So it is not required to my demand.
Now the demand is not satisfied, so I am infeasible.
Because of infeasible, again I don't need to calculate the total cost.
So in the next step, unit 2 alone is getting operating and unit 3 is turned off.
Generating 300 megawatts.
So here unit 1 is off, unit 3 is off, and unit 2 is alone, it operating and it producing the maximum capacity of 300 megawatt, generating capacity of 300 megawatt.
So unit 1 and unit 3 is off. Unit 3 is 300 megawatt and my demand is 700 megawatt. So it is also not required my demand.
Now it is not requiring the demand, so I am infeasible.
Because of infeasible, again I don't need to calculate the total cost.
Okay. So in the next stage, unit 2 and unit 3 both are turned on.
So unit 2 and unit 3 are turned on. So unit 2 is 300 megawatt and unit 3 is 200 megawatt. So totally it's 500 megawatt. So my demand is 700 megawatt. So it is not meeting my demand.
So not meeting, and this is also not meeting the demand. Okay. Now unit 1 alone. Okay. Now the unit 1 is alone operating and other 2 units are getting turned off.
So unit 1 is 500 megawatt. So it is not meeting my demand.
So now again they are not meeting the demand, so I am infeasible.
Again it was infeasible, so I don't need to calculate the total cost.
Okay. Now the unit 1 and unit 3 is turned on. Unit 1 and unit 3 is turned on. Unit 2 is turned off.
So now the unit 1 and unit 3 is turned on. And unit 1 has 500 megawatt and unit 3 has 200 megawatt. So it is totally 700 megawatt. So my demand also is 700 megawatt and it's attained my demand.
So here the generation which is equal to load demand. So the generation which is meeting of the load demand.
Now the generating station are meeting the demand 700 megawatt, so I am infeasible.
As now this was feasible, so I need to calculate total cost.
Total cost. So this solution is feasible solution. We are getting only one feasible solution. Next step, unit 1 and unit 2 is turned on, unit 3 is turned off.
So now unit 1 and 2, unit 2 is turned on and it's 500 and 300. So it's 800 megawatt. So my demand is 700. If it is 800, it's not further we can attain demand.
So now the demand is attained, so I am infeasible.
It was infeasible, so
It was feasible. Only 700 no, 800.
it was feasible. I need to calculate the total cost.
Fine class. So we are getting one more feasible solution because the generation is 800 megawatt, but the load is only 700 megawatt. So we are getting the actual value, record value. And another one, unit 1, unit 2 and unit 3. All the 3 units are getting operated simultaneously and they are start producing the maximum capacity of.
So these 3 units are turned on and producing the 1000 megawatt. So my demand is 700 megawatt. I am attaining the 1000 megawatt, so it is attaining my demand.
Now the demand is attained, so I am feasible.
So now it's feasible, so I need to calculate the total cost.
Total cost. Okay. So here, if all the units are getting operated, it start producing the 1000 megawatt. So the requirement is only 700. So it is also a feasible solution. So out of 8 combination, this one is negligible. Out of 7 combination, we are getting three feasible solution. Out we are getting three feasible solution. So here the 500 plus 200. Here we are getting the exact matching of 700, and we are getting the 800 megawatt, and here we are getting the 1000 megawatt. But the requirement is 700. So in the one solution we are getting the exact 700, and another one 800, and another one 1000. So these three alone, it is called feasible. Others are infeasible solution, whether it's a feasible solution or infeasible solution. And based on the given constraint, that is the given and fuel operating constraint, so here we have to calculate the total cost only for the feasible solution, not for others. For other infeasible solution, no need to calculate the total cost because it is not meeting the requirement, so it is not required to calculate. So for this feasible solution alone, we have to calculate the total cost. So from this total cost, suppose it may be the 1000 megawatt, it may be infeasible, it may be an economical one also, we don't know. So based on the fuel constraint only, we can able to know what is the total cost. For example, here it may be 1 lakh, here 1.1 lakh, or it may be 1.05 lakh, whatever it may be. So here from this cost, which one is the most economical one? So 1 lakh, suppose here you can keep it as 1.2 lakh. So here 1.05 lakh is the most economical when compared to 1.1 lakh or 1.2 lakh. So here we have to turn on all the three units in order to compensate in order to meet the demand of 700 megawatt. So based on the total cost only, we have to allocate which unit has to be turned on. Suppose this is the most economical, we have to allocate only unit 1 and unit 3 is turned, unit 2 is turned on, and unit 3 to be turned off. So, and apart from this, always we are choosing the base load of thermal power plant, because and thermal power plant, if you want to suddenly, if the load is increases, okay, we have to inject more amount of coal and more amount of hot water, more amount of gases into the boiler. So also we have to supply the lot of water to the boiler, and it is getting boiling. It takes nearly 4 to 5 hours in order to convert into high pressurized steam. But so within the 4 to 5 hours, the peak demand goes out. So most of the thermal power plant can be used as a base load, and for peak load we have to choose the hydroelectric power plant or nuclear power plant. So some of the power plant will be used only for the peak hours operating. If you are turning on the hydroelectric power plant, if you are opening the penstock, immediately the water will flow through the turbine. It will immediately drive the turbine. It is that we are getting start producing the electricity without any time delay. So that can be used only for the peak hours. Hydroelectric power plant or pumped storage hydroelectric power plant can be used for peak hours in the morning time, or it may be evening time. So rest of the time we can keep the thermal power plant as a base load. So this is called a unit commitment. Any doubts? Thank you.